Okay, so today's problem of the day says if a car accelerates at 3 meters per second squared while traveling 400 meters and ends up going 80 meters per second, how fast was it moving initially? All right, so we got a car accelerating at 3 meters per second and traveling 400 meters, goes 80 meters per second at the end. So we want to know how fast it was going initially or at the beginning. So, as always, what do we have for our givens here? What's one thing that's given?
3 meters per second squared.
3 meters per second squared, exactly. And which quantity is that?
Is the velocity thing?
Yeah, that's the acceleration, right?
Acceleration, yeah.
Yeah, because it's meters per second squared, right? So we can tell. Okay. What else do we have?
We have the VXF,
Yeah, we have the final velocity, right? The VXF. What's that going to be?
80 meters per second.
80 meters per second, exactly. Great, Danya. Good. One more given. What's the other thing that we know?
We have the delta X.
We have the delta X, exactly. And that is 400 meters. Good. That's how far it goes, right? So there's our three givens. We have acceleration, final velocity, and delta X, the displacement. Good. And so then what's our unknown, right? The last thing we got to get from the problem is what they're asking for.
For the initial velocity.
Initial velocity, right? How fast was it going at the beginning, right? That's our unknown. Good. So we've got three givens, we've got an unknown. Next job is to pick out an equation to solve this with, right? Only one of our big four equations has AX, VXF, delta X, and VXI. Anybody see which one that's got to be?
The last one.
Yeah, the last one. Good, Angel, right?
We don't have time.
Yeah, because we don't have time, right? And this is the only one that doesn't have time in it, right? This has those exact four symbols. Good. So we'll copy that down. Vx final squared equals Vx initial squared plus 2 times acceleration times displacement. So we do have to do some rearranging here, right? If we want to get the initial velocity by itself. But there's not too much. What's the first step I have to do if I want to get this VXI by itself?
I think we need to subtract the 2.
Yeah, well, we have to not just the 2, right? We have to subtract this whole piece of it, right? Because this whole piece of it is being added on to VXI. So you're right that we have to subtract, but we have to subtract this whole chunk. So minus 2AX times delta.
Or we can also divide by itself.
Well, if we divide, we don't want to divide here because the 2AX delta X is being added on to VXI, right? Okay. If it was being multiplied, then we would divide to undo it. But since it's being added on, we have to subtract to undo it. And I'll also subtract on this side. So it cancels out over here. And if I rewrite, I have that initial velocity squared is final velocity squared minus 2AX times delta X. And I'm almost ready to plug in, but I'm not looking for VXI squared, right? I'm just looking for the initial velocity VXI. So what do I want to do to this equation to make sure I just get the initial velocity? I'm going to undo this square, right? How do I undo a square? You guys know this. What's the opposite of squaring something? How do I undo that? No? Square root, right? I would take the square root of both sides, right? Because if I take the square root of vxi squared, then I just have vxi, which I'm looking for. And then I can't really simplify this any further. I'll have to plug it in just like this. Right, so remember, I didn't want the square of the initial velocity, I just wanted the initial velocity, so I had to take the square root. And now I can plug my numbers in. Right, so to get my vxi, it's going to be the square root of the final velocity squared, so that's 80 meters per second squared, minus 2 times acceleration was 3 meters per second squared, times delta x was 400 meters. So plugging this in, I'll do the square root of 80 squared minus 2 times 3 times 400. And that gives me 63.24. So my VXI equals 63, I'll round that to 63.2. And I've got meters per second as my unit. Because if you look here, I've got meters per second, it's squared, but then there's a square root. And also this one, I've got meters times meters is meters squared over second squared. And if I square root that, it's meters per second. And the number seems reasonable because I ended up at 80 meters per second. So starting at 63 seems like that's okay as well. Any questions on this problem? Anybody not sure how we got any piece of that?